LeetCode problem number 33, search in rotated sorted array. So this problem gives us a sorted array that can be rotated like so. And our job is to find target, whether or not the number target is inside the array or not. Right. So we have to return the index of target. Otherwise, we will just return -1. And it's important that our algorithm needs to run with log n runtime complexity lah. That means we cannot just do standard find the nums, but we have to use a binary search instead. So like any typical binary search, we have a left pointer and a right pointer. So I wrote them down here, and then we also have a middle pointer, right? Okay, then I have this while loop here. This while loop is to make sure that both the left and right pointer, basically it will iterate until the left and right pointer meets, right? And then while iterating, we will calculate the mid. Okay, so let's say the example we're going to use is this with the target of 0, right? So how I did it was by using a binary search. I calculate the mid, right? So mid will be left plus right and divided by 2, so this is 3. So our mid will be this number 7, right? So we write 7. This is 2, this is 4, right? Okay, after that, we check whether or not the number mid we are at is the target. If it is, we return, but in this case it's not, right? Since our target is 0. Okay, then we check whether or not the pointer at the left is smaller than the pointer in the middle, right? So whether this is smaller than this. If that's the case, that means we are in a array that is sorted already. And when the array is sorted, we then enter this another if-else statement where we check whether or not the target is less than mid, right? The target is less than this, or no, not or, and the target is more than the left number, right? But in this case, since our target is 0, it is indeed less than 7, but it is also less than 4, right? So this means that our target is not inside this section. It's not inside this left side of the array, right? So what we have to do is we have to move our left pointer to the middle, +1 over here, right? So when we do that, our left pointer becomes 4, right? Because 3 plus 1 is 4. And now this will become 0. Okay. After that, we calculate the mid again. So in this case, the mid is 4 plus 6. 4 plus 6, which is 10. And then divided by 2 is 5. Right. So in this case, 5 will be 1. Okay. Then we check, right? Since it's not, okay, then we check again. So whether or not the number on the left is smaller than the number in the middle. In this case, it is, right? That means we're in the sorted array, where the sorted partition, I'll say, right? Okay, after that, we check whether or not the target is lesser than mid. So in this case, the target is lesser than mid, right? Target is lesser than mid. And then the target is more than the number on the left, right? So right now our target is the number on the left is 0, right? So our target is actually equals to the number on the left. So what we do is the right pointer, this one, will have to move to the left, right? When it moves to the left, then it will be like this. Left is 5, so this is 1. Okay, and then we calculate mid again. So we 4 plus 5, which is 9. divided by 2 is 4, right? And when that happens, the mid becomes the target, and then we just return mid, right? We return 4. It means we found it. Okay. If it doesn't happen, let's say the number was, let's say the target was -1 instead, then the left, is it lesser than mid? In this case, since both are equal, so we still enter this if else statement, and our target, is it lesser than mid? Lesser than equal? It is equal, right? And our target, is it more or equal to left? It is equal as well. It is equal as well. It is equal as well, right? So when it happens, our right pointer will move to mid -1 again, right? So right pointer will become mid -1, become 3. And when that happens, our left is no longer lesser or equal than 2, right? That means both pointers have met. So this while loop will end, and then we will return -1, right? Okay. Okay, let's give another example where our target is 5, right? So let's reset everything. And then, okay, so our target is 5, which at first glance we know it's here, but let's see how our algorithm works. So again, we calculate the mid. In this case, our mid is 3, right? 3, then we 7. Okay, since it is not equals to our target, okay, now we check whether our left is smaller or equal than mid, right? It is, right? Since 4 is smaller than 7, so we enter this. Okay, now we check whether or not our target is lesser than equal to mid. Okay, so target is 5. Is it lesser than mid? No, it is, right? Because 5 is lesser than 7. And then whether or not our target is more or equal to left. In this case, our target is, right? It is more than 4. So our right pointer will move to the left, right? Okay, so when we do that, our right will become 3, so no, 3 -1, so it becomes 2, 2 equals 6. Okay, and then when we calculate the mid again, so it will be 2 divided by 2, so it will be 1, and then you will find target 5, and you just return the index, right? Okay, so let's say if our array is not sorted like perfectly, let's say we dealt with something like this, 4, 5, right? And then this is 6, 7. Let me balance it out a bit. 5. Okay. Then we are searching for target. Let's we search for 5 again, right? Okay. So our right is 4. No, sorry, it's 6. This is 4. 0, 1, 2, 3, 4, 5, 6. Yeah. This is 5. Okay. So again, we calculate the mid is 3. So 3 in this case is 1. Okay, then we check whether or not our pointer at the left side is lesser than the pointer in our middle, right? In this case, it's not, right? In this case, it's not, since 5 is actually it's more than 1. So we go to this else statement, and what this means is that basically this means that we are in a partition that is not sorted, right? Basically this partition is not sorted, right? So we are moving to this else statement. So what this else statement will check is that it will check whether or not the target 5 is more or equal to mid, which in this case it is, and our target is lesser or n equals to the pointer at the right, right? So target is lower than 6. So that means okay, target is lower or equals to pointer at the right. It is not, right? My bad. It is not, since 5 is more than 4. That means our right pointer will move to the left, right? So our right pointer now will be at 2, right? Because 3 minus 1 is 2. And index 2 is 0, 1, 2 is 0, right? Okay, then we calculate mid again. So mid in this case will be 1, which is 6. Okay, then we check. It is not. Then we check again. So whether left is lesser or equals to mid, right? In this case, our left is not, our left is actually smaller or equals to mid, right? 5 is smaller than 6. So we go back to this if statement, and then we check again whether or not target is lesser or equals to mid, right? Since our target is 5, it is also lesser than mid, which is 6, and our target is more than left, or more equals than our left, which is 5. So we move our right pointer forward, our right pointer to the left, so I'll say forward. Okay, so when you do that, it will be mid minus 1. Mid minus 1 is 1 minus 1. I think that's how it works, yes. So it will be 0, it will be 5. Okay, and since left is still equals to right, then the mid, right, so 0 divided by 2 is 0. Then when we look at the number 0, then we found that the target 5 exists, right? Then we just return the index. Okay, so that's all I have to show. Thanks.